Today's class is talking specifically about the Smartware jar file. A jar file, what it is a folder in Niagara full of special objects. Basically, we can find, if you open up your local library, and if anybody's got their laptop in front of you, we're going to open up any version of Niagara. Whichever one you want. Open up your Java desktop environment. And within there, we will be able to see exactly where all your jar files reside. Every piece of equipment in Niagara R2 has jar files within its library. If I can explain that, our hard drive on our own Workplace Pro, we have what we call a local library where all the jar files reside. Our laptops, being more technician based, stores usually all possible jar files a job can possibly have. A UNC, for example, will have jar files placed into it because of the limited resources in them. We only put the jar files in that we need. And we'll have a class someday on when creating a UNC from out of box and creating a station and how we go about putting in the operating system in a UNC and the jar files that I typically select when I load them up. There really are, on a standard BACnet job, when I install an operating system, there's only about 5 jar files I'll load into a UNC. But they need to be in that UNC in order to use these special objects. If you don't have it available already, you can click up on top left corner File, and let's go to Open Local Library. What that will do is down near the bottom you will see C:/Niagara/R2 and whatever version it is you opened up. That is really just a mimic of that folder that resides on your hard drive. And as we expand this, you're going to see the list of folders as it would appear in my computer if you were navigating your hard drive. The jar files, where they all sit, however, is in a folder called Tritium X. And if we expand Tritium X, you will find we have a whole list, and all these little icons look like little jars. Those are all jar files. Some of them are folders because they may store additional, like for example LAN devices. There are literally hundreds of LAN manufacturers out there. Because of that, you can specifically get those manufacturer jar files that will allow you to talk to their devices. And as you can see as I scroll down here, there is a ton of LAN manufacturers down there, and these are all jar files. Now, we're not going to put these jar files into any UNC if we're not using them. It doesn't make any sense. They do take up some space, just like any piece of data on a computer does. The one in specific we are concerned about as you scroll down your jar files is a Smartware. And is there anybody who does not have the Smartware jar file in their local library? Okay, Brian, we're going to have to get that in there because we do no job. Every job that we do gets a Smartware jar file installed on there. Where do we get the jar file from? Where do we get the Smartware jar file from? Is anybody? From where? Where do we get it from? Studio? Alright, Studio is one place. And that's what I'm going to do, is open up Studio right now. What's that? It is, yep, I'm getting to that. It's also on the Smartware website, too. A little bit of history behind the Smartware jar file and how it came to be. When R2 was first introduced in the company, probably almost 10 years ago now, we were excited because of the programming capabilities that it has for us, and we really took off with a lot of the high-end programming right off the bat. One of the things that Niagara offered to us was a form of a free-form programming in something called program objects, and you used to be able to use line-by-line triple programming and make your own unique objects, because Niagara, if you remember the one class we had with the out-of-the-box objects, once you got into more advanced programming, there really wasn't enough out-of-the-box objects to really do what you needed to do. So there came a need for additional types of function blocks to allow us to do certain functions within the UNCs. What happened is the program objects, we come to find, are pretty resource extensive. And we as a company and some of the programmers in those days would get a little carried away with them. And they were writing program objects for every little thing they wanted to do. And literally we were having jobs with hundreds to thousands of program objects in them, and they were bogging down our UNCs incredibly. Needless to say, we were doing everything that factory tells you not to do. And we had to spend a little time cleaning things up, and that's where we got Steve Cohn involved with making the jar files, because the objects found in the jar files are more of a compressed piece of logic. It's not the handwritten program object. They're compressed, so their resources are very, very minimal. So if you can just drag a jar file object in, you're not killing your resources. So what they decided to do back in those days was get together and take some of the more popular program objects we were using and converting them into compressed jar file type objects. We found that there was a lot of must-have objects we needed to have to do what we needed to do. Now, even a little bit more history goes in the development in the early stages of these the Smartware jar file. As the jar file was getting updated, it was unfortunately not getting updated correctly. So what was happening is whenever there was a new version of the Smartware jar file out, and we on our laptops would go ahead and use it, if we were to have that updated jar file installed on our laptops, and if a UNC had an older version, it was completely 100% incompatible, and you could not open your job, you could not work, you could not even upgrade it in a normal fashion that you'd normally upgrade jar files in UNC. It wouldn't work. The upgraded jar file looked like it was a completely different manufacturer's jar file, so it made it very, very difficult. And that's where the jar file switch tool came in, because we found that we had some jobs with these older versions, excuse me, and as a service technician, you couldn't work on your job unless you can match your Smartware jar file version on your laptop with the Smartware jar file that was in the UNC. Am I making sense here, or am I losing some of you? Okay. Now, it's a little hard to explain that. If they didn't match, you couldn't work on it. So they have to match. What's in your laptop needs to be in the UNC, and they need to match. Nowadays, if you have normal jar files, maybe if it was like a properly made jar file, if yours was upgraded, a higher version of the one in the UNC, you would still be able to work on the job. So that's not all jar files. This is just what was going on and how it was incorrectly built back then. So if I go in the studio and I go to the job BCS and I go to software applications, and John, if you or Brian, I'm sorry, Brian, if you want to follow, you can get your jar file installed if you're following along here. So software applications, I'm going to open up this project. Open project. Some of you guys have probably done this 100 times already, but we'll get into the nitty-gritty of the objects in a minute or two here. Within here, you'll see, if you're not familiar with this job, you'll see a lot of our inter-office software tools that we use. For example, customer VPN clients. This is where you'll find the Cisco's and the Nortels and the Sonic Walls and things of that nature. We're interested right now in the Smartware technologies, and if we expand that, you'll see there's your B&B system, Designer Suite, other programs, but within here there is the, where is it? Smartware jar file switcher. Within the list there, you're going to always look for the latest version, of course. We see a jar file switcher setup file, version 1.2.43. We simply just want to right click that object and we want to copy it, and it's going to download it and paste it onto our desktop. And I am going to paste it onto my desktop. Are you able to get that, Brian? Yep. Okay. Is it on your desktop? Okay. Once you get it on your desktop, it's very simple. It's just a double click, and it's going to install the tool, which is, you know, if you blink, you're going to almost miss it. Install. Just follow all the defaults. And this doesn't actually install the jar file. This installs the switching tool. Nowadays, there's really no need to have the switching tool, other than to make it easy to install a jar file. But we need a class on manually installing jar files because it's the only jar file with an install tool. So it's important to know how to actually manually install jar files. We're going to close the exit. Once installed, did you get it in there, Brian? Okay. We'll hit your start button. It'll show up in programs, and you should see a Smartware, Smartware Studio. Yeah, it might put a shortcut on your desktop. We want to run the Smartware jar file switcher. Within there also, you'll see a Smartware file programmer's guide PDF. I've never opened it, but I'll bet you that has an explanation also of all the objects he has in there. Smartware Technologies, and then Smartware jar file switcher. The reason for this tool, again, as I'll explain, is really a few years ago when we had a lot of problems with the jar files. The technicians really needed to be able to switch the versions, you know, per job. They would go to one job and they need this version. They go to the next job, they need that version, and that's the main reason for this whole switch tool. Installing it, you're going to see a box comes up. The first selection in the box, install Smartware jar file version. This is going to have all the possible versions. You're going to see old version 1.3, 1.41, 1.50, 1.5. All those old versions are the troubled ones. Those cannot be properly upgraded. You can't even upgrade an old version to a new version doing an old upgrade. You literally have to get rid of all the old version Niagara objects out of this UNC. You got to get them out of there all together, hopefully, and then blow it out of there and put in a new version if you want to use a newer version. We're going to scroll all the way down and we're going to select new version 0043. and you need to install it to whatever Niagara version you're using, and what's going to happen is it's going to find all the versions found on your machine. You can do 529. I recommend doing 529 and 522. They're the two more popular versions we're using now. We'll select 529.
Bill,
Yes.
what was the latest Smartware version jar file available?
4.3 on Studio, but Aaron Barkley informed me if you go to the Smartware website, you will find a version 4.4 there. Yes. You're going to want to upgrade from the 3.5, Mike, because I think the OSS had a lot of work done to it. So if you, or if you want to manually go to, I know with version 4.3 now, a customer had a conversion job done from Steve. There is a problem with the loop lock. So if you're using the loop lock on any job, which we normally don't use loop locks up in the UNC, but just in case you are, we found a bug with the loop lock. I don't know if Steve had fixed that not or yet.
I get that from the Smartware website, the latest files.
You can go to Smartware, get 44, but that one you're just going to get the jar files, and you have to manually install the jar file, which is fine. And I'm going to click Install Smartware Jar File, and you'll see jar file installed successfully. One thing to keep in mind, your Niagara, in which I made a mistake right here, Niagara cannot be opened when you do this. Stations cannot be running. You want to make sure Niagara's closed. If it is open, you just got to close it out and reopen it again, and the changes will then take effect. So you're not going to break anything. You're just not going to see it. You're not going to see the objects until you restart your Niagara. Anytime you do jar files, you shouldn't have, if you're doing it on your own machine, you just close out your Niagara. If you're upgrading a UNC, of course, you need it open. But we'll go into jar file installation in another class. Now what I'm simply going to do is just find any kind of job that I can open or run a little something on my own machine here, or I'm going to, let's see, open localhost. BCS 060. And I'm going to start my own little personal. I have a project I call development, and that's where if I need to play around or something. So I got a project open. And I'm just, oh, that's a big one. Okay, here's a container. I can wipe out everything in here. Okay, now I got an empty container to play. I'm going to scroll down into my Tritium X folder, and I'm going to expand my Smartware jar file. You're going to see 4 containers in there. One's called conversion, one's called GCM, one's called objects, one's called specific, and one's called SW, which stands for Smartware. Mike, I know you specifically asked about some of the conversion ones. Conversion objects, a little history behind them. They got really popular back in the LAN days when we found customers were using certain snivet types that did not have the out-of-the-box links available up in a UNC. So a lot of times we were finding we were having to make homemade objects that can link properly to a LAN device because of the snivet type it was. They had some pretty strange ones out there, and that's where conversions originally started. Nowadays we don't see that so much anymore. The other use for conversions were when we were trying to do large pieces of programming in a UNC, and we found that we were trying to often convert uh, like a float status output to an integer, or take an integer and spit out a float priority, or take a float object and turn it into a binary, and that's really what the conversions are going to do. There's a couple that I find I commonly use in the BACnet world these days. What I like about them is you can use other objects to come around, but the conversion objects are nice and small, and they're easy, and they make your programming look a little neater and nicer to the eye, as opposed to using a big fat math object just to convert a float status into a float priority. And when I expand the conversion, some of the more popular ones and the easier ones to figure out, for example, the first one is BP to BS. And someone tell me exactly what the BP to BS is doing. It's a binary priority to a binary status. And I'm going to copy and I'm going to paste one in. And simply, when we had our other class where we talked about the out-of-the-box objects, and I tried to explain a little bit, there was differences between status outputs and priority outputs. And priority outputs have a priority array, and they do not link to each other. So take a BP, for example, to a BS. Maybe, for example, we have a BACnet object, and specifically a BACnet object called a binary set point. A binary set point will only take a status. It has a status input, so it can only be linked to a binary status output. So if we had some programming, for example, that only spit out a priority, we could not link the priority to the input of that BACnet object. And let me know if I'm speaking over your heads here. And I can't pull out, but for example, I'll take a standard out of the box. Whoops, I don't want that. A standard out of the box binary input. And we're going to pretend that this is a BACnet object. I'm going to rename it to binary SETPOIN set point. This would represent a value we're sending down to. Let's pretend this is the schedule. In the schedule, we didn't want no right-click functionalities on this block or anything. We just wanted a straight single shot, and you'll see on its input side of the object, its input is an SIN, which stands for a status input. There's a difference between a priority input and a status input. And if I take something like a logic block, and you'll notice my logic block has two outputs. It has a priority out and a status out. There are some objects that only have, when you get into nitty-gritty of programming, you'll find there are some objects that only have a priority out. That's it. You don't have a choice. You only have a priority out, and I need to convert that priority out to a status in, so that we can link this up properly. And if I try to link this to my BI, you'll see if I highlight priority, we'll just pretend that that's the only output on this object. You'll see on the BI there everything's red. It won't let me link it to anything. So what I can do is I can take my BP to BS and I can place it in between. I can link to the BP to the BS prioritized output to the binary input, and I'll say OK. Now I have a conversion that converts the priority to a status, and I'll properly be able to now link that to that BACnet object, pretend BACnet object, and there's our conversion. That's how that gets done. The same goes to this next one is interesting. BS to FS. What do we think that does? Say that again. Okay, it's binary status to float status. Now, a lot of times in the world of playing with these jar files, and it's kind of corny, but when I get bored, I'll open up jar files that I'm not familiar with and start pulling out objects just to see what they do. You know, I play with them. I said, what does this do? And you're going to find the same case with the Smartware. Let's pull this guy out and let's figure it out for ourselves what it does. I mean, it's obvious we have a binary status input and a float status output. Why in the world would we ever want that? So let's go, and we're going to go into the properties of this object. I'm going to go to the config tab and see what we got to play with. And this is pretty interesting to me. When I look at the config, I have a default input, I have a true value, and a false value. What does the inside of this object resemble in a very, very commonly used object in every product line we've ever worked on? What does this compare to? There's a very popular programming object we use, whether it's microzones, UNCs, plant controllers, GCMs. That's it. It's a select block. I can take this guy. I can say for a true value, I want you to spit out 100. False value, I want you to spit out a 0. Now we have just properly converted. And I'm going to link up a little quick binary output to that guy just to show. We're sending it a false, which is 0. If I make this true, we just spit out 100. So it's really a select, but it is also kind of a conversion. BS to FS, just what it says. The next one, FP to FS. Anyone? Float priority to float status. All right. Identical to the BP to BS, except instead of a binary value, it's more of an analog value, or in our 2 world, it's a float. So if you hear me say the term float is the same as saying it's just your most commonly used analog type value in R2 is a float. So it's more of an analog value. And I can link that up identically to the way I did to the BP, from the BP to the BS. If I wanted to go through and link that all up, it'll look identical. We get into now, there's more specific, and every time you see something like, all right, who can tell me what FP to HVAC mode enum is? Mr. Rob, who answers all the questions. Decoder ring. Paul, you tell us.
It's a float status, which, I'm sorry, float priority is using FP, right?
Yep.
The HVAC numerator we have a structured snippet in some cases in Smartware where we basically copy this command point where it actually spits out if we're in different modes of operation, being HVAC world, heating world, economizer, that type of application there. In this example, this is going to, this is basically in the LAN world. I don't think we're using this in the back world.
It's strictly LAN. Yep, what it is, it's a strictly LAN device. There are some LAN devices that may have, and if you know, and we got to have some classes about LAN. I know a lot of people don't have a lot of experience with LAN, but LAN used to be everything. We used to eat, sleep, walk, talk, LAN. It's all we ever did for a long time. Up until about 4 years ago, maybe. And there were certain things that you'd use snivets. If you knew about snivets and LAN devices, you were limited to the amount of back and forth points you can send in and out of a controller. You're limited. So we had to make use out of every possible LAN object there was. And then there was also the third-party devices like train chillers and boilers and things like that were LAN devices where they had structured snivets that were unique just to the manufacturer. So we would have to often create objects to be able to link to them and send data back and forth. Whenever you see something similar to this, and you'll see others as we go down, there will be they're very specific to LAN controllers. Next one down the list, FS to BS. This is a pretty good one. It's more like a high-low, almost like a thermostat blocking away without a deadband. Float status to binary status. I think. How does this one work? I think maybe not. Let me link up an AO to it and see what it does. That's how we figure some of these out. So you guys may find yourself out there in the field and you need a piece of logic to do something, and that's what you do. You hook them up and see what they do. I have a 0. It's giving us a fault. I have false. I have an idea that if I see, just like in workplace tech or in microzones, any value greater than 0 and it's going to be an on. And I'll bet you if I even go as high as a 1 and I link that up and I send a 1, it goes to true. So that's all it is it's saying, just like in all of our programming logic, any value greater than 0 is an on, a true, and anything 0 or less in the negatives is going to be a false. Clean that out of there. FS to FP. Float status to float priority. Oftentimes, those are very popular in BACnet when you're using the specific BACnet objects, analog set point priority objects they call them, because you can only link up a priority array to them. And we'll find that if you're using one of those for an outside error, you want to send outside error down to a controller. Oftentimes I use these objects a ton, float status to float priority. What you don't see in here, interestingly enough, is a binary status to binary priority. Why? I don't know. I like them, but if you, for example, if you take a logic block and you make it an OR, there's your conversion right there. Your logic OR is typically you send in a status input and you get a priority output, and you can use a logic OR if you want to convert, make it that way. I think the program lib jar file, which is another popular jar file to use, has the conversion in it if you like to use a smaller specific conversion object. And they have a ton of them here, and yes, they do have a BS to BP here. But we're not talking about that one today. That sums it up, Mike. Was there anything else specific you wanted to see on the conversion portion? The rest of them here are pretty much snivet related. If you want a larger selection of the BS to BPs and the integers to floats and floats to integers and things like that, the program lib jar file has a lot of conversions to choose from as well. Actually, they barely have any LAN, and they have mostly, float status to integer, float status to multi-state output, integer to bits. They have a lot of them there as well. Are you good on that, Mike?
Yeah, I'm good. I just, haven't had a chance. I see them installed on jobs, and I don't have the luxury of having a lot of time to figure out what's going on with it. And sometimes you run into like, what are they doing here? So it's just nice to be able to go over them and get some idea, what we use these things for.
If the job is a BACnet job and it's been done in the past few years, the conversion is most likely going to be used to pass down to specific BACnet objects.
See, I've run into roadblocks on BACnet, trying to get values in or out of controller space, and don't know how to do it,
Right.
I'll clear up some of that. So.
Right. Well, that's a part of it. That's a part of it. So it depends on which, if you're using a certain, if you want to send an input, a value down to the controller, it depends if you're using the analog set point object or are you using the analog set point priority object. And the priority one is going to have the priority array, and the plain analog set point is going to have just a status input. So oftentimes we have to convert it depending on where that value, what object it is that we're linking and sending it down to.
Like anything, the more you work with it, the more you figure out. I've run into situations where I've needed to know how to do things, and it's like, how do I get around this,
Exactly.
That kind of thing.
The next container down from conversion, we have GCM. So a lot of you old-timer Network 8000 programmers, this is a pretty friendly container to you guys because a lot of people are very familiar to the objects that you'll commonly find in GCMs, and a lot of people are very comfortable with using these objects. These were giving, keep in mind when you speak to Steve about these objects, Steve was given, how do you want to say it? Schneider Electric actually did give Steve their interpretation of these objects and how to programming, and they're nothing more than, I guess, how does Steve say it? It's his interpretation of what they're doing. So Steve was never a Network 8000 programmer. They do all work. They all work. Most of them work well. There's a few bugs here and there in the most part, but as we just recently found in the loop block. But that's hard to find because it's very rare that we even put a loop block up in the head end anyways. But if you're a little more comfortable, like, we just noticed earlier there was a conversion object, and we found it's very similar to a select block. But if you're not comfortable with using that, you can come to this folder and grab a good old-fashioned GCM select. Copy, paste it in there, and there's your good old-fashioned select with the ability to use it as a binary select or an analog select. OSS X is the very first version of OSS that when Steve was doing his conversion jobs and he needed an OSS object because the GCM had OSSs, it's nothing more than a plain OSS that allows you to have your Monday through or your Sunday through Monday start and stop times. It did know. Yes, it's a schedule. It's all it is. But it was needed to convert, and then eventually he did go on to make the other. Yeah, I can see the confusion there. And now that he has a real OSS, I think the OSSX should simply be removed altogether. One thing about the new OSS, if you don't like the way it's functioning, and you want to say, I just want a plain schedule, there is a value, I forget which one it is, I think it's this bottom one, the FRTAB, that allows you to just completely, if you hook a binary up to it and turn it on, you can just completely disable the OSS and use it as a schedule if you have to, if you find yourself in trouble or something. So this can be done if your OSSs are going absolutely ballistic and you can't seem to control them. You can just disable that and it'll just work with this schedule. So in my opinion, yeah, the OSX should probably be removed. I don't think it's negligible. We can find out. Let's see here. Let's see if we can do this. View, edit. Where's the resources? Oh, no, I can't. There may be a little bit bigger. It's nothing I would concern myself with, Mike. Once it's compressed and turned into a jar file, you can use as many as you want. But when we had 800 of them as a program object, that's what was killing us. Yes, but there are also ways to link up to those. Yes, you can link to those with special objects. And we had that in our other class, as a matter of fact. It was the way we were able to graphically display and show how we adjust, like, alarm limits with analog command type objects and stuff. But, no, you're right. If you did have a dynamic analog values, you'd probably want to use the select out of the GCM because it gives you the ability to link float status to it.
Yeah, old-fashioned stuff does have some value, doesn't it?
Yeah, it does. We've gone as far as I have some jobs with a ton of univents, and as big as the clunky as that OSS object is, I've not even come close to killing a resource count on these UNCs. So with these jar files, I wouldn't worry too much about the resources. And here you'll see all the other, you'll see sequence, RNet, resets, everything you'd possibly find in your GCM. If you want to know how they work, what I do is I open up my old-fashioned GCM programmer's manual, and you'll be able to look up every one of these objects and see how they work, because that's how we program them with the exact same inputs and outputs and attributes. Next down the list, we have a container called objects. I'll be honest with you, I don't think I've ever really used anything out of here, but they have, some of them you just don't know. They were very specific and made like 8 years ago, and you don't know what some of them I don't even know what they do after playing with them. Some of the popular ones in here, though, I don't know, current date and time. If you wanted that displayed on your graphics, see, nowadays we have a banner, though, that displays that for us all the time. But if you wanted something, you can just drop this object in here, and it just grabs the clock information. You go into run mode, it grabs the clock information, it'll just spit out, and then you can link that to a graphic GX text if you want to display date and time on a graphic. Annotation, nothing but Steve's signature. No, I don't even know what this object does, to be honest with you. You can just play, yeah, it's not exactly notes, but yeah, you can just display stuff with it, I guess, in a string format. Degrees, conversion, edge. Some of them you got to read, and you'll figure out what they do. Edge, pulse, BS. And I'm going to guess that this is going to give us some kind of a pulse. Yes, a duration, and I'm going to set a duration of 7 seconds. And I bet you it'll take if I take a new control binary output and I try and link it to the edge pulse. If I turn my binary output on, active, I get a true on the output, and I'm guessing that'll go off in 7 seconds. Yep, there it goes. So this object, just by playing with it, we figured out will give us a pulse, like a momentary, isn't it, in a way?
Pulse it in either direction, too. True or false.
Oh, does it?
Yeah, run it the other way.
Okay. Well, I'm sitting in the false right now. So if it was true. Oh, so just a change in change of state. I gotcha. So we go to inactive, and it'll pulse it again. So interesting. Edge trigger. This is going to do the same thing, except it's going to have a trigger out. And the trigger out we find is handy. Some objects work on triggers on their input. Trigger it, it performs a function. It's going to be the same thing, except you don't see with your eyes the output of the trigger. If I linked up my, and you don't get adjust the duration either. A trigger is just like a trigger. You pull the trigger and there you go. So what'll happen in monitor mode, you'll see on the output of that, it'll just say trig, but you won't know unless you can link like a little override object to the trigger output to see if it works. Like I'll just real quick add a binary override. I'll go into the properties real quick, configure it, make my override value true for default for 1 minute, and then I'll link the trigger output of the edge trigger to the override trigger of the override object. And now what will happen is anytime I have a change of state here on my BO, goes active, true, and there you see my trigger went and activated my override. Now my override output is in an override state, and it'll stay there for the minute. Flip-flop. Flip-flop's handy for lead selects. Except I've never used this flip-flop in particular. I'm guessing that's what it does. Oh, and it uses a trigger. So I can probably link the trigger to this guy. Trigger, output trigger. And what will happen is the way the flip-flop will work is every time you see a change of state, his output will go to true. Then the next change of state, it'll go to false. And a lot of times I'll use that to, oh, this thing's bouncing all over the place. Yeah, I don't know what the heck this object does. Somebody figure it out someday. That's pretty crazy.
Flip-flopping. What do you think it's doing?
Yeah, you know what, Mike? You're right. I think that's what it does. Is it sits there and flip-flops.
I'm not sure what you use it for, but it's doing it.
Yeah, it is. It's just sitting there flip-flopping. Okay. That's kind of like G3 has now an object, they call it random. And all it simply does is you put a low value and a high value in it and a duration, and it will just randomly spit out a number between, you know, it's like rolling the dice or playing the lottery or something. It'll just randomly spit out a number within the duration. Format seconds. That's always nice because if you take something like, if I take my BO object here and I pull out this format seconds object and I link the BO, you're going to see I have is seconds in, and you're going to find a lot of the objects in the inside only keep track of time in seconds. So a lot of times you got to take those seconds and convert them up to minutes and hours and days even sometimes. So I will link up the status elapsed active time to the seconds in, and what that allows me to do then, if you need to do some run times, you want to link a runtime in hours or something to a graphic, you can convert your seconds into hours, convert your seconds into minutes, or convert your seconds into seconds. Or in the time, it has string outputs. Mine is actually showing 2 minutes and 46 seconds, you know, to a T. So if you needed to show that, that's fine. IO tester, no idea. Never seen it. I don't think I've ever even pulled this one out. So we're just going to skip over that. Some of the other good ones in here, min-max, average sum is nice. If you ever try to do that in R2 world with just the out of the box, you'll find yourself stacking math objects on top of math objects on top of math objects. Yep, this is nice because min-max, average sum. You can paste that in and right away you get 16 inputs to play with. Same with the multi-state logic. It's another big up to 32 logic blocks, and I think this one's configurable to, no. Yes it is, function. And, or, exclusive, or not. So up to 32 on that. What I don't like about it is sometimes that's too many. And I mean, all in all, you can pull it out and use it and have, maybe 9 items linked up to it, but I like to, just me, I'm fussy, I keep my programming neat and tidy, and I try to keep the space, easy to follow, easy to read, and a lot of times I don't use one that is quite that large. What's nice is the high-low in the GCM container. There's the old-fashioned high-low that works very nice. You have up to 8 inputs on that one. The interesting thing about the GCM, let me pull it back to the GCM one again, because if anybody did a lot of Network 8000 programming in the past, a lot of times if I need a simple T-stat block, I resort to the T-stat block in here because I like the deadband in it and things of that nature, and we don't have any place else that has a normal T-stat. So if I pull out a T-stat object, one thing I want to point out in its defaults, you just can't link to this thing and it's going to work. And anybody who did a lot of GCM programming, you'll find that this has burned you in the past as well in GCM world. But if I go into the properties of this and I go to the config tab of my tstat object, your max set point and min set point by default, just like in the GCM, is 60 and 90. Okay, a lot of times we do other functions with a tstat block and our set point is outside of that range. Our tstat block is not going to work. I don't know if anybody remembers getting caught by that back in the GCM days, where you just created the block, set your set point, and the object just wasn't working the way you thought it was. Come to find out that you needed to expand your max set point and min set point. That happened to me many times. Other objects, user info, swap Fs. Like I said, you just got to play with them. Some of them are a little self-explanatory. I'll go through and look for something that may be what I'm looking for. I'll pull it out. I'll link to it. I'll look at the properties, and you can kind of figure out what it does. To the next container down, specific. Specifics, we're going to find some pretty crazy ones in here. I don't think I've ever used anything out of this container. These were created back in the days when they really wanted to take some of them high-end program objects and convert them in. BO helper binary alarm, BO helper analog alarm, change of state chiller enable. I really don't know what that does. I think it's probably nothing more than a tstat block maybe. FS loop, I mean, yeah, you can tell this is looking for a loop in a valve position or something, and it's obviously very, very specific. Select analog max 65. Yeah, interesting. Select analog max 65. Outside air temp is an input. Discharge air temp is an input. Like I said, very, very specific. I don't know what we would ever do with those right now. The other area I want to get into is probably my favorite Smartware object altogether, is under my SW container. How many of us have And we find this a lot in service, especially when we really want to take care of our customer, and maybe we want to go out of our way and we want to make things like all the decimal places read the same graphically on our job. And in today's world, we find out that, you know what, I don't want 2 decimal places. That's silly. But we know when we do external links, we lose the ability to control the amount of decimal places, because external links will always resort back to 2 decimal places. And if we're linking externally right to a graphic screen, we're kind of hosed in a way. And we're like, wow, I spent all this time making all my others, all my temperatures are, just 1 decimal, all my valves and dampers and percentages, I got no decimals on them. That's the way I want my whole job. And when my set points all got to have 2 decimals on them. We need to, I am going to take it's my favorite one on the bottom. It's called an SWGX text. Okay, and one thing I'm going to do is I'm going to go and I'm going to grab an out of the box GX object and a GX text. And I'm going to paste it into my container. And then I'm going to grab this SWGX text and also put one in my container. Right now, they both look identical. And what I'm going to do is I'm going to grab a new analog output object. And I'm going to link the status out of my analog output to both of the bindings of my text objects that I put on my screen here. Link. Okay. Now both objects, side by side, they look identical. I am displaying a value of 0.00. If I go into the properties of my AO and I go to my visual tab, this is not an external link, but what I'm going to do is I'm going to make my precision 3. I'm going to take my manual set and I'm going to make that, I'm going to call it a manual set. I'm going to make auto. We'll just leave it. Auto is going to be auto. I'm going to get rid of my emergency set and emergency auto. I'm going to go back, and as we're going to see now, we're going to see a 0.000. And I'm going to change my value. I'm going to go manual set 10. Now we got a value of 10.000. Now, if this was an external link coming from a UNC, we would have no choice but to use the default 2 decimal places. And we'd have no choice with that unless we were to actually create an object in the server, link it from UNC to server object, and then adjust the decimal places there. So I'm going to go into the properties of my. If I go into my GX text real quick, properties, you'll see there's not much there. My config tab does have some basics. Check your font, display binding text, border colors, border width, foreground colors, the basic stuff. Under the visual tab, if I'm going to have a hyperlink to it, status color enabled, flashing enabled, display units abbreviated, and highlight commandable. If I go into the properties of my SWGX text, you're going to find a few more added items there. Under the config tab, you're going to see the basics, and then below border width, you're going to get this mapping, where the mapping's kind of interesting because I can link up to 3 different objects to this object, and the mapping is looking for an integer, and I can change the color of it based on my integer value I'm sending. And I know I'm not making a lot of sense here unless I was to really pull out objects and display that, but we're getting a little short on time. But also I want to show in the properties under the visual tab, okay, this is the cool part, is halfway down you're going to see where it says decimal format, and you're going to see precision 2. I'm going to set that to 1, but the line just above that says apply analog decimal format. So right in my GX text object, this allows me to turn this to true and bypass the default. It basically blocks what I'm getting from the object, and he's controlling it. He's taking control of it himself. So if I go back, now you see I've got a 10.0 on my graphic screen there, which is really, really cool for those external links if you're really getting fussy on your decimal places on your graphics. Another place that this will save you behind is if I go back into this object, under the Visual tab, engineering units. Display, let's see, where can I find them? Where am I? Here it is, units. I can select the units from here. If for some reason, remember we talked about BACnet objects and maybe somebody didn't set the units down in the controller level and we learned the object and now we need some units for it and we're finding in our BACnet object itself we can't change the units because it's pulling out what is known in the controller. Well, here we can go, we can set the units right in the SWGX text, and then the line above it says apply analog units. We can say true to that and say, okay, we're going to use the units of this object, and we're gonna block what you're sending up to me from the object. Same thing with the binary down below. Apply binary text. If we need to change that because maybe we configured a damper end switch to be on as open, off as closed, and come to find out later on after the job's all been started up, it's really reading backwards. You want to go in there and reprogram your workplace tech program and re-download and everything, or do you just want to use a little smoke and mirrors method here to reverse that graphically? You can do the same thing, use binary text to true, and put in your own, whatever you want it to read. Maybe somebody screwed up and they did a lot of copy pasting, and it says open close, but it's really a start and stop, and you're like, oh crap. Gosh, do I want to go all the way down to workplace? Maybe we're working remotely here and can't even download to the controller, so it's a way we can make it look nice on the graphic. So that is very, very cool. I was very, very happy when that object came out. Sure. There is a limit. I'd like to say maybe 8. I remember we came across that to some lawn stuff that Rego was working on too long ago. Can you hit that button? Because he needed some big ones written up, and I said, yeah, I can create them up for you, and ended up that we were limited, and I'd like to say around 8 or something like that. Maybe even 6 to 8. Yes.
So it's not useful for more digits. It's more useful for less digits. Adjusting.
Yes, unless the only cases where I've gotten into 3 digits is when we're monitoring room pressure. When you get into room pressure, you need that 3rd digit because room pressure is very, very minute value.
But you have to get that one right down in the UNC test, rather than it doesn't help you this one.
It pulls it out. It pulls out the 3rd decimal. It will not pass. If I set that object in the UNC to be 3-4 decimals, and then I link it directly externally, it'll by default give me just a 2. So, but I have to turn it back to 3 or 4 on the other end to get that to display. But it will display. It will pull it out of there.
Yeah, if you get it right.
Yes. Yeah. Other items we have in here, if you see that we commonly do notes on our modern graphics, you'll see some of the graphics have now you can right-click graphically, and each graphic will have, you can enter notes. The object we use most commonly from here is this SW command string. The reason we use this command string is because the standard out-of-the-box string command, if you reboot your UNC or server, you will lose the string it had in there, and then you'd lose the note that you left on your screen. The SW string command does nothing more than make sure it retains your note that you added, so it stays there upon a reboot. The other thing, SW analog set point and SW binary set point, you will commonly see. We won't use those to program. You will often see those on conversions, however. And that's all I've got to say about those. They're big, large objects. They do have a lot of functionality. You want to pull one out, boy, they've got everything built into them, from overrides to state, colors, what state they're in. They do all. It's a big, large, fat object. I haven't really found use for it yet when I'm developing from something new. It's really used in conversions. Flex, and then some of the other stuff, these flex strings. Flex strings 4, flex strings 16. I had Steve make these. I tried this out on one job, Lewiston Porter. I got so tired of customers and projects changing room numbers. And I wanted to come up with a way to say, I'm going to allow the customers to make their own room number changes on the graphics. However, though, the important thing about that is, when we edit our logs and our log descriptions, we put the room numbers and everything in there. So every time the customer gives us a room number change, we would also have to go in and edit all the logs to match, which is why I, get so aggravated. And it's pretty impressive. It's a lot of programming to do, but I had Steve make these, and these flex strings will actually then link to the description field of the logs, and I can set up some other blocks where I can make the room numbers a right-clickable changeable item. And when you change your room number, you're actually changing the log description. It links right up to the log descriptions and changes them there. Changes everything you would need to change if you made a room number change. So it kept things nice. But realizing it was pretty programming intensive to do. It was a lot of heavy programming to do it. So I did it on one job. It works great. It's fantastic. It's beautiful. It's gorgeous. You change the room number and your log description changes with it and everything. The customer has total control of it, but boy, it's a lot of programming to set that sucker up. But it's there, and if anybody really wants it for one of their jobs, I'll be more than glad to show it to you. With all that being said, that is the breakdown of the Smartware jar file. Any questions? Did I miss anything? Anything we want to review, cover, look at? Nobody?
Sounds good, Bill.
All right. Well, that concludes it. I have a doctor's appointment at 10 I have to get to, so we're going to wrap things up here. And thank you all for coming.